robot and all that stuff. Now I can start recording, right? Not there. Okay. The first line of this is S is equal to serial, parentheses COM4 bracket that there. Now the COM4 is, come on in, that there. COM4 is the fourth serial port on this computer right there. Now, you'll get into the lab next week and you may find that it's not on COM4. It may be on a completely different COM port. And the only way you can tell is, actually, we can just bring up the, right here. And I don't know if we can get access to it, but you may just have to guess. But the way I find out is I go to Manage, and I open up the Device Manager, and under the Device Manager, I've got this one thing here that says ports, COM and LPT. LPT is a line printer port. It's a parallel port used to talk to the old style Centronics IEEE 488 printers. We don't have those printers anymore. I don't think anybody in this room's ever seen one. They had a great big connector on the back of them that was about, I want to say about this big. I mean, it was about the size of a pack of cigarettes. About there, maybe not quite that big, but it was a pretty good size port there. It's like maybe 3 times the size of a cell phone, thickness-wise, and about half as long as a normal cell phone. They were big ports, huge. And the cables were huge because they had like 16 wires in them right there. So we don't use those anymore. You know, the COM ports was the RS-232 COM ports. They have 3 wires, receive, transmit, and ground, and then some handshaking wires up there. Well, we don't have the COM ports anymore. So built into this particular box is what they call a USB to serial adapter, where it looks like a serial port to the computer right there. And this particular one is on COM4. So you may get into the lab and discover it's on COM3 or it's on COM5. It's going to be on one of those 3 typically, 3, 4, or 5. And you just try your luck until it works if you can't get into the screen right there. But on the serial port that there, you have to figure out which COM port, because this thing here, I can unplug it right here. And of course, you see it goes away. I can plug it back in right there. And it's still on COM4. Sometimes I can unplug it and plug it back in, it shows up on COM3. It just depends on what else is on the computer and the mood of the operating system. But if you can't get to the computer management screen, then you just pick one or the other of the 3. And I'll give you this program. I'll upload it on Facebook between now and next week. That they're a little test program just to test to make sure everything's working right there. So again, that's our COM port. So our first thing in our code here in MATLAB is that we go and we open set S. S is just an arbitrary variable name, and we say that it's a serial port at COM4 right there. Then we set the baud rate for this right there. Now this particular program is talking to an Arduino microcontroller. I had most of you in the 8051 microcontroller course. I remember seeing everybody in this room, I think at least once. So I either had you in microprocessors or I had you in microcontrollers. I don't think I had anybody here in digital. I might have had 1 or 2 of you in digital. It's been a while since I taught digital. I only taught it one time, and then they took it away and gave me this course instead. Lily said she was happy teaching digital because that's the core course that everybody's had. She wasn't happy jumping in here and trying to teach robotics out there. So I got nominated for this class, as I complained about before. And I enjoy it. Actually, I have fun with this class because I get to play with the toys. Okay, so we set the baud rate right there. Then we open the serial ports. All 3 of these lines here are just to open up the communications between your computer and the Arduino microcontroller inside this box here. And Probably next week I'll bring a screwdriver, we can open the box up and people can look inside of it. Don't do it in the lab though. Don't bring your own screwdriver and take the box apart, please, okay? These things are about, you know, we did spend 10,000 ringgit for them, and we don't want in there playing with the wires. And to be honest, these wires, don't be gentle with them. We found that if you pull them too tightly, that bad things happen. Okay, anytime we do anything with this particular robot, we have to pause it. Right there. And that's simply because it takes time for the Arduino to process the data and do something with it. Now, what we've got here is that there's an order in which we have to write things. And the first thing we have to do is we have to set the speed. Now, he changed this, the way that this is working now, we set the speed once and we leave it set. It doesn't change right there. So, but we're going to just simply write to the serial port the number 92. This is just simply an 8-bit unsigned integer is what that means right there. U is unsigned, INT is integer, and 8 is the number of bits right there. And we're writing the number 92 to it right there. And if we want to run it faster, we would set it at higher speed. Now his comment was that's about 80% speed. He didn't give me a whole lot of documentation for it. As I recall, the speed went between, I think, like 40 and 120 or some weird number right there. And that has to do with the way the Arduino processes it. So we could say that 80% is 92, so full speed would be whatever that is, right there. So 92 times 10 divided by 8 or something like that would give you what that is. So that there. We have the pause. So we set the speed. So this is only done one time. And again, I'm going to review this and kind of write this up as part of a lab assignment up there. But I wanted to just kind of spend today just introducing you to the robot there. Then we'll get back to the boring stuff later. This is actually more fun than the boring stuff. Now we've got 6 motors. They start with motor 0 right there. Now, as we look at this right here, and I'm going to pull my pen out right here and talk about our motors right here. The first motor right here is the one that rotates around right there. So this is motor 0, and that's mounted inside this box right here. Right there. So this rotates this around, and it will go between 0 and 180 degrees. Now, not all these robots, 180 degrees and 0 are at the same place. Right there. We just discovered that they mounted that there, and if I had it to do right, 0 would be straight out here, and 180 would be straight out here. And that's the way it should be mounted, but it's not. We'll see. You'll see that here in a few minutes. There's no repeatability on these robots. They don't repeat themselves very well. So our next motor is mounted on top of here, right here, and that moves this arm right here, and it goes this way and this way. And that's motor 1, right there. Then we have another motor, another actuator here, right here, and this is motor 2, right there. So we can see motor 0 is in here, motor 1 is here, that moves this back and forth, and I'm going to unplug this and turn this off. The reason I can do that is so I can move these motors. This is motor 1 right here. This is motor 0. This is motor 2 right here. This is motor 3 right here. And this one right here. 3, then 4 should be right here. And then 5, it moves this right here. So 0, 1, 2, 3, but no, 3, 4, 5. 5 is the pincher right there. So you can see the little pincher right there. So now when I turn this thing back on, it'll snap back to attention. Right there. Right there. Right there. Okay. Let's get this back on where it goes. Okay. Now, the instructions are, and close up there. The instructions are, if I can find my MATLAB here again, that right here is we're going to move serval 0 to 0. Now, I'm just going to highlight this code and just run that little piece of code. So I'm going to go ahead and, right here, excuse me. So I'm going to just run this little piece of code right here. And what this is going to do is it's going to open the file and write to it, set the baud rate to 9600, and it's going to then set the speed to 80, and then it's going to move motor 0 to 180 degrees. So you should see this thing turn right there. So let me just run section, and now it's turning right there. And that's 180 degrees. And, oh, did I hit? What's it going here? Oh, it's running the entire program. I don't want it to do that. Got there. Well, I wanted to do it piece by piece. Got there. So it's running the entire program. We'll go through and I'll set breakpoints so that doesn't happen again. Right there. But as you can see, it's at there, and then I'll do the top one here. Right there. What's that set to? What did I have that set to? Okay, it's both. Okay, let's. I'm just going to put a breakpoint on every pause. That way I can go through and got a lot of breakpoints here. We've got a lot of movements to go through. We don't. Oh, okay. Motors 4. Okay. All right, I'm going to start from the beginning again. So this will go up till the point that I'm going to set this thing to right there. So it's paused right there. So now this is motor 0 is set to 180 degrees. Now, those of you that are in the front, you can see that's actually pointed about 45 degrees out. given a choice, I would take this apart, move it over, and then put it back down. Right there. But to go through and do that with all 12 or all 10 boards we've got will take some time. They're all off a little. So pay note of which one you're using. This one is number 1. It's got the little Cobra-1 on it right there. It's actually got, no, this is number 8. It's got the Bluetooth pair 88888 there. That tells you which one it is. The Bluetooth pair tells you what board you've got. Right there. So this is board 8. So if you're going to, there is a Bluetooth program that you can use instead of connecting it there. The Bluetooth program is of not, I consider no use whatsoever. It allows you to set one motor at a time using a Bluetooth program. And you can't do it programmable like this right here. So that's why I pushed that we had them working with at least MATLAB. You know, I was hoping for C or Visual Basic. We got MATLAB is what we got. All right, now we're going to turn the same motor to 0. Right there. So if you can see here, I'm moving motor 0 to degree 0. Right there. That's the command for doing that. F write, which is file write, to the serial port, a unsigned integer 8-bit, the number 0 twice. So when I run this, right there, all it's doing is moving it 180 degrees over to the other side. And if you look at it, before it was sticking out about here, now over here it's sticking out about the same. So it moved it approximately 180 degrees right there. So right there, that's motor 0. Motor 0 is rotating the arm. Next, we're going to move motor 0 back to, where are we at here? Right there. I lost where we're up. It looks like we're on line 12. Is that where we're at? No. Okay, well, we'll figure out where we're at here. Because the last thing we did was my little break point doesn't, oh, here we are. That's what I was looking for, is that green arrow right there. You see the green arrow? I lost the green arrow right there. So, right there. Our next move is we're going to move this motor to 90 degrees. So we just moved that motor to 90 degrees, and we see it moving to 90 degrees right there. Again, if I had it to do, I would take that apart, and 90 would be facing straight out there. So again, you know, I've made complaints about these robots not being perfect, and I said, all right, I can use them this way. They're good enough that we can use them there. But in an ideal case, this would have to come off and get moved over to where it's actually at 90 degrees. So for the lab, you're going to just put something at a place, and you're going to figure out where it's at. So what your job is, you're going to just put an object up, say like this right here, and then you're going to come back, and you're going to take a picture of that right there, and then you're going to go through and figure out how you would pick that up. You don't have to move it anywhere, just pick it up. So in other words, you would put it this way to where it's like this here, and I don't care what it is. You know, this is probably not a good choice. Probably a perfume bottle or something like that, where you could then figure out what your angle is from here, and then you would figure out how you would bring it down and how you pick it up. You're going to find that that's going to take you a couple hours, you know, in a group of 2 or 3 of you to sit down and do that. But you'll get a good idea on how to program this motor robot by the time you're done. So, and of course, part of your lab is you're going to have to videotape it doing that. So, and it's cheating to figure out how to pick up something and then show me the picture afterwards where it was at the beginning. You're supposed to place it someplace first and then figure out how to pick it up and show me that you can pick it up when it's marked at the same place at the same place, right there. So, okay. Now we're going to move motor 1 to 0, right there. Motor 1 to 0 is this one here. And that goes all the way down to where it almost touches the ground, right there. So, that there. And again, you'll notice it's supposed to be at 90 degrees. It's not quite at 90 degrees, right there. And then we're going to turn right around and we're going to move this to 180. And this does not go quite 180 backwards, because if it did, it tear up a few wires and things. So it's actually hitting these wires and just it's stopping that there. And then we're going to move that back to 90 right there. Now notice in our move instructions, there's two instructions for a move. And the first one is we're telling which motor, the second one we're telling the number of degrees we want to move to, right there. So, right there. Now we're going to go to motor, we're going to now go to motor 2. And motor 2 is this one here. And we're going to do the same thing. We're going to go from 180 to 90. So here's 180, right there. Here's our motor 2. And again, it's not right at 180. See, it would be if this was right at 90, it'd be closer. But you can see this thing's got some slop in it, right there. And that's why there's no way that I could sit down and make you go through all the math anyway, because these robots aren't accurate enough. If we went through all the equations and they work exactly the way they are supposed to, up there. So there's our 90. Our next move is supposed to be to 180. So this should go almost straight up and down. Maybe straight the other way. And that's a little weird. Huh. Okay. Hold on here a second. Oh. That's a typo here. This should say 20 right there. Or 0. That was why it was off so far, because I got 20 there instead of 0. So, right there. So that's 180. So if I move, next time I do this, it'll probably go to closer to the 0 mark right there. And this should take us to 90. And that's pretty much right on. So these look pretty good there. And this one here, we're going to move 3 to, I copied this from his, I think he put 0 in just simply so they didn't press it to the limit that there. We'll leave this at 2160 right there. So again, that's taking us to 20. And this takes us to 160 the other direction right there. We're on motor 5 right there. Right there. And where's my little green arrow? There's my little green arrow right there. Oh, we're on motor 3 right there still. Right there. And now motor 3. And that's a little weird. Oh, okay. Now we move motor 4. I didn't put a brake in here, so I moved 2 motors at the same time. I'm not going to go back and put the brake in. So it moved motor 3 this way here, and then it also moved motor 4 because I didn't have the brake right there. And then the last one is we're going to move motor 4, not the last one, but we're going to now move motor 4 here over to 90 right there, or be to 180. And then we're going to move it to 90 right there. There's our 90 degrees right there. And then those of you that are in the front, you might be able to see this here, but this is the gripper. Right now it's about half open, half closed. Now it opens a little bit, and now it closes first. Or it just closes a little bit, doesn't close all the way. Right there. And then 180 closes right there. It opens a little bit, and then it now closes. Now remember, when you pick something up, don't set it all the way to 180 to pick it up. You've got to set it to where it's tight enough to pick it up, but if you set to 180, you're going to strip the gears out on this thing here. So loosely pick it up. there's a little bit of rubber in here to kind of pick something up that there. You got to be a little bit careful. If you set it all the way to 180, you're going to, like I say, strip the gears, set it up to like 150, then set it to 153 or whatever until it's close enough to pick it up right there. So in other words, to pick up something like this pin, I'm going to set this to like 140. Right here, I'm going to remove all my break points right here. And I wanted to stop it, I want to set these to 0. And stop it. Set this one to 180. And then there was another one I set. This one here, I think it was when I set the. I just wanted to see. Oh, I didn't clear that break point. That came a lot closer to 0 that time. Yeah, you see, it's still a little tight to pick up something with this pen. I set this to 140, so let's try 120 right there. And again, you can go through and you can just delete out the code that you don't want to use right there in order to. So I could grab these 3 lines right here. You see, here I'm only playing with a couple motors right there. Right there. I'm just turning that motor. Now I didn't close the file, so next time, right there. See, now that it's closed about the right, it needs to be a little less than that there. So I say, and I didn't close the file in here, so that's why it gave me that error. And I need to and it's not going to let me work. I have to unfortunately, if you forget to close the file, you almost have to reboot. Right there. So, right there. But we saw that 120 is a little bit, not there. So you have to try, you have to play with that number to see how close you close the gripper. And I'll explain that again next week when I talk about what the lab's going to be. Today's lecture really was I'm just seeing whether or not if I. Turn it off, turn it back on, whether or not Nope, I got to reboot. It's locked. The problem is that I opened the file and I didn't close, the port, and I'm trying to reopen it. It keeps giving me an error, and then when I try to close it, it's all mucked out up there. So when you write your code, you have to remember that you open the port with those 3 lines. At the end of your code, you have to close it with these 3 lines right there. So that there, and if you don't do that, you're shutting your computer off and back on. Right there. Okay, let me just kind of summarize where we're at. I probably didn't talk long enough for a class that's supposed to last for 2 hours, but I never talked for 2 hours anyway. So that there. But there's a lot to cover here. At there, we've got 6 motors. One of the things you have to figure out, one is part of your lab report, is what type of those 5 motors that we talked about last week is each one of these motors go to. Now, the top one looks like a linear, right? That there it's a linear joint. This is definitely a rotational. These look like pivots right there. This is a rotational right there. So, in other words, identify which of the 5 joints we've got, which each that there. This actually is an actuator at the end right here. Then, so you've got motors 0 through 5. The lab, and just start thinking about it, is that we place something at there, and I don't have anything to place there, but let's say, pretend this is a small bottle of nail polish for the ladies. That there, I don't know how many use nail polish, but that there, I can't think of anything. That the guys would use that would be small enough. That's the key thing is, it needs to be something about this tall and fairly small in diameter. And something like a nail polish or a perfume bottle is almost the perfect size because it's got a narrow top that you can grip. That there. So I can't think of, it could be your watch. There's, something like a watch, but a watch is kind of hard to grip. If you put it there, how are you going to grip it the right way? But, well, what's that? Let's see what that is. That there. Yeah, there you go. This is what I'm talking about. Right there. Now, this one may not work because this one may have too big a top. But you just set that there. Right there. And let me see here real quick. This one would work perfect right here because you would just barely close it right there. You make sure it's open all the way, and then it would be. So this is what lipstick. This is lipstick. Okay. Again, I'm picking on the ladies because they almost always somebody's got something in their purse that would fit for this right there. So you just simply place it someplace on the table right there. It doesn't matter where. Now, this I should point out it does matter where because this robot actually only has an arc, and you can that you can move like this right here. So anything closer, because we have no way of retracting or expanding the arm. So if we want to pick something up, it's got to be on this arc right there. It has to be on this arc right here. Right there. Right there. Anything off that arc, if I put it out here, it won't reach it. If I put it here, it won't be able to reach it. So we're really narrow. Now, if we could theoretically reach something out a little bit with this right here, if we stick it out this far. But the way this robot's designed, you're really on this arc is what you're limited to. So when you place it on the arc is where it has to be. But there, all I want you to do is just reach down, find it, pick it up, and just hold it there, and just put it back down again. That's all that's there. Now, in a pick a place assignment, we would tell you to pick this up here and then move it over to another place and drop it down, come back, get the next one, pick it up, and move it back down. Right there. And that's how a pick-and-place robot would work. Here, she can have her that there. So, but again, who's this belong to? Is that yours? That's there. So, So, I lied to you when I said any place on this table. You're very limited on where you can go on this table because it's got to be on this arc. What I'm saying is this table looks like this right here. This robot arm can only go on this arc right here. That's the only place it can go because we have no way of moving in and out right there. So it does have that limitation right there. So it's got 6 axes, and we're short one to being able to complete. Because ideally, the first generation of these they bought before I got here, they put a checkerboard here, and they were going to try to play checkers. And when you pointed out the arc to them, it was like, oh, can't do that. That there. Then they went back and took off all the checkerboards. That there, because we can't do checkerboards. Play checkers or chess with this. Actually, a chess piece is not a bad thing to use. Also, instead of the lip gloss or the perfume bottle, you could use a queen or king off a chess piece, or even the pawn. They're about the right size you can pick up and move right there. So, but this is really at there. So this is what the robot arm looks like. We spent a couple of weeks talking about robotics, what it's used for, all the social stuff. And then we kind of went through all the various types of actuators out there. Now you get to see one out there. Now, which room is our lab scheduled in? Anybody remember? Yeah, scheduled. Yeah. This won't be this Friday because this Friday I'll be in Malacca for a gathering. So, but I'm trying to figure out which room it's scheduled for. It's scheduled for 323, but what my plan is to give the lab assignment next Tuesday. I'll write it up between now and Tuesday. That there, I will kind of go through what the lab looks like, and then I'm going to all these boards are in the UniKL faculty office. You're just going to see that we have no place to put them, so we just set them on desks all over the place out there. So they're in no particular order. When you get a couple hours to work on this, just go grab a board, you and a couple of your friends, work on the lab, and if you get done by Friday, then you don't have to come in Friday. That's the whole idea. I'm going to just open it up. I'm going to give instructions out there, but it's almost all experimental. Now, again, you can outline this is between 0, this is 0, and this is 180 degrees, and then you put your piece there along that arc. All right, this is going to be somewhere around 75 degrees right there, or whatever it is right there. You know that it's going to, you're going to look to see what's 0, and here's 90 is up here, right there. So to pick it up, you need to know that it's going to be somewhere right around here, right there. So you can kind of guess what the degrees are. There are going to be guesses because, as you well see, this thing's not calibrated. So if you measured it precisely, you're going to be off anyway. So, and then just tweak your guesses to where it picks it up, right there. And again, you don't have to move it anywhere. Again, the moving is actually easy. All you do is once you pick it up, you just move it to the other place along the arch, set it down, and then reopen it. That there, and then pick it up, and you're done. That there. So actually, the moving part is actually fairly easy. It's being able to identify the two places. But you really, once you identify the first one, then you've got, the angle in which you got to be to set it down. That there, and that there, and you know what this is, and then you can only move it along this arch, right there. You can only move it along that arch. Is the only thing. Now you can turn it this way and reorient it, but you can still, the movement is only around the moving motor 0. Moving motor 0 is the only one that allows you to actually move it right there. Motor 5 or motor 4 allows you to reorient it, and motor 6 lets you set it down, and of course motor 1 is what lifts it up and down out there. You can actually ignore motors 2 and 3 for the most part. Out there, motors 2 and 3 can be ignored. Almost everything is going to be in motor 0, motor 1, that's motor 3. Right there. So yeah, motor 3, you have to get this position on right there. So motor 2, this one here, you can ignore. Just set that at 90 and forget about it right there. So, but this one here, you have to get to where this is straight up and down. So, again, the whole idea is not to be precise, is for you to sit down and play with this and program this and see how you move these right there. It's just 2 commands for each move. You tell it what motor and what degree you want to go to. Everything else, is fixed. This will be the fix for everybody right there. Those first 5 lines will be part of everybody's code. Yeah. This Friday? No, I won't be here this Friday. Yeah. Next Friday, we will have class if you still haven't finished the lab. But the lab is scheduled for next Friday, but you have the option of doing the lab before Friday. In other words, you go get the board from the from the ICO office, go next door, because we're going to have to do the lab next door anyway, because that's the only lab that's got enough computers with MATLAB in it. So if you're going to do the lab, you got to do it in that open lab on the 6th floor, right there. This is where you've got to do the lab, and I'll explain that on Tuesday, next Tuesday, because that's why I don't want to spend time talking about it, because I'll have to go through it again Tuesday anyway next week. But what you'll do next week, though, is Tuesday I will explain the lab, and I will post the instructions on Facebook right there. And I will go through Tuesday, and I will run a short little demo of what the lab should look like. Hopefully I can get it working on next Tuesday, Monday, Tuesday, right there. I will show you what the lab looks like, right there. And then the boards will be in the ICO office on the 6th floor. So after Tuesday, anytime you want, just come to the ICO office, get a board. Go next door, do the lab, take your pictures, take your video, right there, because I'll put some drop boxes on e-learning for you to submit those right there. I won't have a lab report, but you'll have a little picture, then you'll have a video of the working, and there'll be groups of 3. And I'll explain that in more detail how that's going to work. But there will be a write-up, but there'll be a picture and a video that you have to submit. So someone's going to have to videotape your lab working with your phone. And then you'll save that to a file, and then you'll put it on. You'll put it as a file in e-learning. Right there, you'll just submit the file as part of your e-learning. Right there. But you will do that, and truthfully, it might take you 30 minutes. It might take you 2 hours to do the lab. It depends on how lucky you are. And I hate to use the word lucky in there, but sometimes it is lucky. Right there. But, right there. And once you've got a video of you going and picking up the perfume bottle or the lipstick bottle or the chess piece or whatever you pick up, you pick it up and you set it back down and you open the arm and open it, pick it back up, you're done with the lab. Right there. You just have a short video of that right there, where you place the thing there on the board someplace, and then the arm comes down, picks it up, and sets it back down. That's what essentially the lab is, right there. So you have to go through assigning it there, assigning the motors, to whatever degree it is, moving it down, closing the gripper, picking it up, setting it back down, opening the gripper, and picking it back up. So you have to outline your movements that you want to make. And then you have to figure out what the values are for the movements right there. But I can tell you right off that you're going to have one movement to move the motor 0 in the right area there. You're going to have another movement to move this in the right spot, probably another movement to move this in the right area, another movement to close the gripper, another movement to pick it up, and then another movement to put it back down, open the gripper, and pick it back up. Right there. And maybe return this back to a home position. Right there. So that's essentially what the lab's going to be. So you're going to have a series of movements that you have to go through. So you have to kind of write up what those movements are You know, and that's part of this robotics class is you have to figure out how you're going to do something. In this case, we're going to pick up her lipstick bottle right here, and we're going to pick it up, and then we're going to set it back down. Now, I could have just easily said, I want to pick this thing up, and I want to move it and set it down over here. Right there. That's there. And all I have to do that is just move this over here and set it down, maybe oriented this thing a certain way, and set it down there. You know, we're going to do a couple more that are a little bit more complex. But the whole idea is just to see how you would actually use a robot, program a robot. Right there. And this is without a teaching arm. If I had a teaching arm, I would just sit there, be there moving it with a joystick. Right there. And I'd lower down with the joystick, hit the close button. It would have the sensor in there to know exactly how close it is. Right there. We have no sensors in here, so that's why you got to be careful, and you have to do trial and error to figure out how close the grippers have to be. Right there. So there's a fair amount to this lab. It's not going to be 10 minutes in and out. It's going to be right there. So again, today was really just to show you what the robot looked like and how we program it, and I did not intend to get this deep into the lab discussion yet. The lab discussion is really reserved for next Tuesday, where I go through step by step what you're going to do in the lab, and then you've got the week to do the lab right there. So now, if I thoroughly confused people, if I scared anybody, it's actually not that bad. I mean, but at first it's going to be kind of frustrating because it's not going to cooperate.